Namaste to all. I am Dr. Nikita Jain, Assistant Professor, Department of Mathematics, Mewar University. In this video, we discuss about the topic inverse of matrix. A non-singular square matrix of order n is invertible if there exists a square matrix B of the same order such that AB is equal to IN is equal to BA. In such a case, we say that the inverse of A is B and we write A inverse is equal to B. Here non-singular means determinant of any matrix is not equal to 0 is known as non-singular matrix. And singular matrix means determinant A equal to 0 is a singular matrix. The inverse of A is given by A inverse is equal to adjoint A upon determinant A. Here adjoint means transpose of cofactor matrix is known adjoint matrix, and necessary and sufficient condition for the existence of the inverse of a square matrix A is that determinant A not equal to 0. So necessary condition determinant A is not equal to 0. If determinant A is equal to 0, then singular matrix and we not find the inverse of this matrix. Next, properties of inverse matrix. If A and B are invertible matrix of same order, then first property inverse of A inverse is equal to A. Second property A transpose to the inverse is equal to A inverse transpose. And third property is reciprocal properties. AB inverse is equal to B inverse A inverse. Yes. Next, find the inverse of the matrix A is equal to 1, 2, 3, 4. So, if we find any inverse of matrix, then we check this matrix is square or not. Square matrix, that means row in equal to column. So, here 2 cross 2 square matrix. So, we find the inverse of this matrix. So first we check determinant of this matrix. If we get determinant equal to 0, then we cannot find the inverse of this matrix. So first we check determinant of this matrix. So 1, 2, 3, 4. Determinant of this matrix is 1 into 4 AD minus BC. That means 1 into 4 4 minus 2 into 3 6. 4 minus 6 is equal to minus 2. So here determinant A is not equal to 0. So we find the inverse of this matrix. First we find cofactor of this matrix, and cofactor of A, that means C11, is delete first row first column. Here 4, so we write 4. And next C12, cofactor of C12 is 3, so we write 3. But C12 is the position of 1 2, means 1 plus 2 3. So minus 1 to the power odd is equal to minus, so negative sign. Yes, next 3. So 3, cofactor of 3 is 2. Again the negative sign because odd place. And cofactor of 4 is 1 because it is an even place. Yes, this is a cofactor matrix. Cofactor of A is equal to 4 minus 3 minus 2 1. And next we find adjoint matrix. And how to find adjoint? Adjoint is the transpose of cofactor matrix, and transpose, that means row change into column and column change into row. So here first row element is 4 minus 3. So we write first row in first column. So 4 minus 3, and second row minus 2 1 write in second column minus 2 1. So we find adjoint of matrix A. Okay, next we find A inverse. So formula of A inverse is adjoint A upon determinant A. Already we find determinant A is equal to minus 2. So minus 1 by 2, and adjoint matrix, put the value of adjoint matrix is this 4 minus 2 minus 3 1. So this is A inverse. A inverse is equal to minus 2 1 1 3 by 2 and minus 1 by 2. Okay, next we find the inverse of the matrix A is equal to this matrix. This is a 3 by 3 square matrix of third order. That means 3 row and 3 column. So same process, we apply the formula A inverse is equal to adjoint A upon determinant A. So first we check determinant of A. If we find determinant not equal to 0, then further process, then apply the further process. So first we find determinant of A. Determinant of A is equal to A11 and C11 means cofactor of first column plus A12 C12 plus A13 C13, and cofactor of C11 means first row and first column delete, and remaining matrix is this -1 4 2 1. So C11 is equal to determinant of -1 4 2 1. So here -1 into 1 -1, minus 4 into 2 8. So -1 minus 8 is equal to -9, and C11 is the position of even position, so we not change the sign. Next we find C12, and C12 means first row second column delete. So 0 4 minus 2 1, and multiply 0 into 1 0, minus 4 into minus 2 minus uh, minus 8, and minus already signed, so plus 8, and 1 2 is odd position, so we write minus, change the sign of odd position. Okay, clear. Next we find C13, 1 3 1 plus 3 4, even position, so we write not change the sign, only we write delete the first row and third column, and we write this, and find the determinant of this 0 into 2 0, minus minus 2 is minus 1 is equal to plus 2, so is answer is plus 2. Similarly we find another cofactor C21 C22 C23 C31 C32 C33. Similarly we find all cofactor, and then find adjoint matrix. And how to find adjoint? Transpose of cofactor matrix is adjoint matrix, and we get the inverse of this matrix and apply the formula A inverse is equal to adjoint A upon determinant A. Here we find determinant A is equal to 1 and put the value of adjoint matrix is this. So we get the answer A inverse. Thank you.